All right, we put a lot of effort into finding the derivative of sine of x, and we will be rewarded for that because that was actually the last time that we're going to have to use the limit definition in coming up with our derivative rules. Everything else we're going to be able to get from things we already know. So now we'll be able to get the derivative of cosine of x using things we already know about sine of x. So we want to compute the derivative of cosine of x. We could do it the long way using the limit definition, drawing some similar picture, but let's see if we can find a shorter way. Cosine of x and sine of x, as we talked about in week 2, are very closely related, right? They're each horizontal shifts of one another. In fact, if I take the graph of sine of x and I shift it pi over 2 units back to the left, that will move this point right up to here, and I'll get cosine of x, right? So the derivative of cosine is the same as saying the derivative of sine of what? How do I shift pi over 2 units to the left? Do I put a plus or a minus? So remember from the first night that if I want to shift to the left, I put a plus there. So cosine of x is the same as sine of x plus pi over 2. I think we have an old applet. You can shift them if you like and experiment with that if you don't believe us here. So what does this mean? Now we want to take the derivative of sine of x plus pi over 2, but because we have the chain rule, we know how to do this. We've got the derivative sine of something. So the chain rule says it should be cosine of that very same thing. Right? We just figured out that the derivative sine of whatever is cosine of whatever. Chain rule says now I take the derivative of the inside function, except in this case, what's the derivative of x? Derivative of x is just 1. The derivative of pi over 2 is 0. So that's just cosine of x plus pi over 2 plus 1. So you could memorize that the derivative of cosine is cosine of x plus pi over 2, but there's actually a cleaner way to look at it. Cosine of x plus pi over 2 means I'm taking the cosine graph and I'm shifting it pi over 2 units to the left. So when I shift the cosine graph pi over 2 units to the left, this point here moves to the origin, and that should be a graph that you recognize. That's the graph of what? If I shift cosine pi over 2 to the left, I get the sine graph flipped around the x-axis. So this is negative sine. So as easily as that, we got our derivative of cosine. The derivative of cosine of x is negative sine of x. And again, if we weren't using radians, we wouldn't get this nice clean answer, but radians are great. And if we've done sine and cosine, we should do tangent. How do you think we can do tangent using things we already know? What rule could we use in knowledge of tangent? Tangent is sine over cosine, right? So if I want to take the derivative of sine over cosine, we can build on what we know. We know the derivative of sine, we know the derivative of cosine, and we know the quotient rule. So the quotient rule says I take the derivative of the top. The derivative of sine, we figured out a little while ago, is cosine. And then we're supposed to multiply that by the bottom. And then remember the quotient rule we have to subtract. That's why the order matters. Now we leave the top alone, sine, and we multiply that by the derivative of the bottom. The derivative of cosine of x, we just figured out over there, almost for free, was negative sine of x, all over the bottom squared. Sure would be nice if this simplified, wouldn't it? So writing cosine of x times cosine of x, sometimes, I mean, you can write it like this, but mathematicians really try to avoid parentheses whenever they can. So typically, they write that as cosine squared of x, right? That's what we mean by cosine of x times. That's what cosine squared of x means. It means cosine of x times cosine of x. Here we've got minus minus, which is plus, so sine squared of x. That numerator should look very familiar, all over cosine squared of x. In fact, as we just discussed in the last video segment, if there's only one trig identity you know, it's this numerator. Sine squared plus cosine squared is 1. So this is 1 over cosine squared of x. And we actually have another name for 1 over cosine, right? Do you remember from week 2 what trig function we call 1 over cosine? That is secant. So this is really the same as writing secant squared of x. If you want to write it as 1 over cosine squared of x, that's fine. We, grading your work, will recognize that that's the same as secant squared. But this seems to me easier to write, so that's how I'm going to write it. So we can add this to the list of derivative rules that we have. The derivative of tangent x is secant squared of x. And we're not going to write out the formulas for the other ones. You don't need to know them. If you want to figure them out, you know how to figure them out. Cotangent, cosecant, secant. You can always write them as quotients involving other functions that you already know, and then take their derivatives that way. So now we know that our basic three trig derivatives, in our next segment, we will practice using them to find some derivatives of specific functions.